Okay, we're a bit late, so I'll just dive in. Welcome to my talk. I'm James Thomas from CodeThink, and this is about Gitlab CI and using openQA to test full system images. A brief bit about me. I'm an engineer at a company called CodeThink. We are a UK-based Linux consultancy firm. I've been there for nearly 15 years now, and in that time, I've done quite a lot of things in the automotive sector. I used to work for Nokia, and all of these things involve embedded systems that we really need to do a better job of testing. I'll skip this. Okay, who knows what openQA is? Okay, it's a good job I've got this then. So openQA is it's been developed by the SUSE project. It is a set of tools that enable you to take a file system image or a disk image or a CD image or something like that, a full system image, and it allows you to test it. So it does a complete set of tests on the actual system itself. There are two components to this. openQA is actually the web UI for this, and OS Auto Install is the thing that actually runs the tests. As I said, it takes an image file, and the major way of doing these tests is to actually do a screenshot comparison. So when you run the tests, it will look at a screenshot that it expects and then compare it against the one that you actually see. Most of these tests work in QEMU, so it's an emulated environment. You can get it to work on a piece of hardware, so you can have a CI pipeline where you're flashing the image and then you run these tests, but that's a little bit harder, so I'm not going to explain that today. And there's a few more links there, so you can go and check it out. The SUSE project obviously uses it. Fedora uses it. I think Debian uses it. A colleague of mine has done a lot of really good work for the GNOME community, so check the tests out there, because that's actually a very good example of everything I'm going to explain today. So here's a brief overview of the types of reports you get. So this is a screenshot of a test report. And you can see here that all the tests are passed, and you can see they're grouped by various different things. But what you get there is a screenshot. So when you look at a test result, you can see the difference between what you saw and what you got. And this makes it incredibly easy. It's really, really neat, this. It makes it very, very easy to see if something went wrong, what exactly went wrong with the test. And one of the areas I think is actually particularly brilliant for this is actually doing localization testing. Because if you have a system that's supposed to support a dozen languages, I don't think you're ever going to find someone to do any manual testing who can speak a dozen languages. But if you know what the language is supposed to look like, you can compare it against a screenshot to make sure that all of these things work. I have used this in the past for an automotive client to do exactly this level of localization testing. So what is the actual test? So there are two components to this. You have a needle, and a needle is just a combination of a screenshot file and a JSON file. So it's a screenshot and a description of what it is you want to match in that file. You've then got a test. Now it's actually, so openQA itself is written in Perl. It certainly wouldn't have been my choice of language, but it's quite an old system. But the actual tests themselves are written in Perl, but it's a very, very simple variant of Perl, so you don't really need to worry about the Perl side of that. So then you put them in a Git repo, and then you can run the tests. So this is a needle, essentially. So on the left-hand side, I have a PNG. It's a clock. It is a very simple Qt example, I think, QML example. And on the right-hand side, you can see the JSON information there. So the green boxes are things I want to match. And you can see that's just referenced as the XY position and the width and the height, so it just draws a box around them. And there's a threshold there, 95. But you may also want to exclude things from the match. So the red box there is in, I don't care about this, because if you're testing something like a clock, obviously the clock's going to change depending on what time of day you run the test. So things like that you don't necessarily want to match, so you can exclude them. And the top left corner there is a click point. So you define that in the same way as you would any other area, but you give it a click point. Now, it's a pretty new feature, and it's actually something CodeThink contributed to openQA. you can now use multiple click points in a test. And that becomes very, very useful when you have, say, hub-based workflows that you would get in a vehicle. You can use the same needle with different click points, and then you don't have to recreate the needle 10 times. And so here is a basic test. So as I said, it's Perl, so there's a run function, and everything about the test happens in this run function. Now, reset home is something I wrote for this test. You can extend it very, very easily because it's just Perl, so you can really, really write your own things. But the main primitives in openQA are these assert screen. So you can see there's an assert screen and a certain click. So assert screen basically means, did I get to the screen I'm asking for? So I'm referencing home there, and home will be the name of a needle. So then it will go off and look for that, and did we match it after 10 seconds, yes or no? Again, launch amp, swipe, RTL, they're things I've done there. So here's the swipe RTL. It's literally a convenience function to say, simulate a swipe gesture. It goes from right to left. So mouse drag is one of the things you can do, but I didn't want to do this every single time in a test, so I've written a function for that. So the architecture of openQA, so it runs in Podman containers, and it's actually very easy to set up. All of the Podman containers that you need are in that URL. Very, very easy to build, very, very easy to run. The two essential ones really is the openQA web UI, and you need the worker image as well. You don't actually need the openQA web UI to run tests. So if you were only interested in running tests and getting a pass or fail, you only actually need the worker image. But in my opinion, it's really good to have the web UI because you get those reports. You get a very, very easy way of being able to see what exactly went wrong with the test. So the worker image contains everything that you need to actually run the tests. It has QEMU in there and everything. It has the virtualized environment, and openQA manages them. So this is the openQA architecture from the documentation. Now, the way openQA expects you to use this is you go to openQA and you post an image. You've got something you want to test. And then openQA itself will manage all of the workers. So the worker is like a machine that you've added to the openQA pool. And openQA itself will find one of those workers to run the tests on. It'll go off and run the tests, and it'll bring them all back to the web UI. Now, it's quite important here because this WebSocket REST and NFS interface between openQA and the workers, they kind of recommend that you use an NFS share to share data between openQA and the workers. And that is a nightmare. That is a real difficult thing to manage. So what I'm going to suggest now is going to be a much better way of dealing with how to synchronize things between the worker and the openQA. Because the really important thing there is both of these instances need to have the same copy of the needles and the tests in order to be able to get any kind of like meaningful results. But for our GitLab use cases, we have a project, we're building a system image, and it's a GitLab project. We push a change to it. We do the build, so we generate that image. This goes on a GitLab runner. We then want to test that image, so we pass that image to the test stage. That also goes in the GitLab runner. Now, with the normal openQA architecture, that GitLab runner would therefore have to trigger openQA, upload the image again, and then have openQA send it off to another worker. And we don't want to do that because we already have a runner. We want to manage our build and test infrastructure within GitLab. So let's try and keep it in there. So thankfully, this is possible. It's a little bit of an odd use case, I think, for openQA, but it absolutely does work. So, I mean, conceivably as well, I'm not that familiar with GitHub pipelines, but I think they work broadly the same. So you can also use this with GitHub as well. So In our test stage, we will download using needs, so the test stage will have the image. We will use the same Docker container as what openQA provide, but before we actually launch the worker that's in that container, we're going to create a unique ID so that when we tell openQA we have a test job, openQA knows to trigger it on the GitLab runner. So, moving to GitLab, you need a test repository. For this example, it's a very, very simple one. You have your needles folder and your test folder. One of the recommendations is that you separate the needles and the tests, so you have a separate needles repository, so that contains all the PNG files, that contains all the JSON data, and you have a separate repository for the actual tests themselves. I really don't like that workflow. It's kind of, you're introducing more complexity, you have to merge things in two places, so I just tend to keep them together. You need some variables. So these first two ones, you don't want to put them in your CI file because they're tokens that you will generate in openQA. So hide them away in the protected variables. Now the ones you do want in the project, you want the host, so the location of where openQA is. Now the openQA test git variable here, this is how the worker is going to know what version of the tests you actually want to use. So I'm giving it a Git HTTP URL with a CI job token, which is a GitLab thing. So when I clone this, it will be able to clone it on the image. You'll want to put the SHA in there because you need to know the exact version of the tests that you want. And this worker class at the bottom, this is how we're going to target it. So CI job ID is always going to be unique because they increment every single job. So we can use that to say the type of worker that we're running here as this particular extension. And because it's a QEMU job, we just call it QEMU. So the first thing we do is we get rid of the existing config that the openQA worker image has, and we create our conf. So this is just going to say openQA host from these variables, connect to this with this key and this secret. This is how we define the actual worker. So we're using the backend QEMU backend, so it knows to use QEMU there. Worker class is going to be that thing we just defined with the job ID, and the host, again, is just going to be openQA host. Now, we already have the image in our test stage, so we need to move that image into a particular place. It may not be called apps image for you. It's whatever your Yocto project builds or whatever your build root project builds, but it has to be in this HTTP folder. So now we can start the worker. We can collect the log, but we want to run that in the background. So this is how you actually launch the job. So after you've run the worker, you've now registered that worker with openQA, and you can now tell openQA, I want to run a job, and I want to run it on this worker class, which is the last line. So that will run it on the GitLab runner that we have. Most of that there is, once you start to get familiar with openQA, you'll know what that is. Distri is just the name of the tests. Version is the release we want to do. Flavor, you can have like an ISO or DVD or something like that. They're just openQA variables. The really important thing there is the case-dir and the needle-dir. So that's how openQA, that's how the test runner will know which version of the tests to run. So this is going to be really important for the types of workflows you want to do, because you may be testing on a different set of needles and tests to what was on the worker. And so this can actually synchronize that very, very easily based on those variables. So this is very, very useful to put in there. So once we've fired that off to the openQA API, the job ID there, you do want to collect that because that's going to be your reference. Now, this is very long-winded, but thankfully there's a much easier way to do it. You want to wait for that job. So the job ID you got in the previous stage, you want this test stage to pass or fail depending on the results of those tests. So you need to define a job check function that will call the API and just go, what's the status of that job? What's the status of that job? And now you can do that in a loop. So you can go around and check the state constantly in a loop until it's done or cancelled. Once you got through there, you can check various different things. If it passed, brilliant. If it was cancelled, it's a failure. If it failed, then it's a failure. And then you just exit with that code. So then the GitLab pipeline will know whether or not it failed. All of that now can be replaced with this new command, openQA schedule -- monitor. So you can create the job, you can wait for the job, you can do it, and that will also print out a link to the tests. So I think it's quite a new command, so I've never used it myself, but the documentation just use that. You don't need 24 lines of bash. And now we've got test stage. So I've got a video of this. I was going to do this live, but I'm not insane, so I've recorded it. Yeah. So this is the build project. So this is the thing that's building the image. This could be a Yocto project. It could be a build root project. It could be whatever. This is just generating an image. This is actually build stream. It's GNOME user and things like that. Now, what this project is doing is bringing in various different apps. It's a very, very simple one. So there's about 3 apps. But it brings in some apps. These are all in Git. These are all different projects. And we're integrating them into the image. And we integrate these by the ref. So that's just a SHA. And you can see now in the pipeline, we've got a build image. This generates that apps.image I was using before, uploads it to the GitLab artifacts. Now the test stage here, we've waited for the job. It's passed. We can click the web UI, and we can see now that everything's passed. So here's the web, the needle editor, the needle viewer. You can see all the different things I'm trying to match on there. Very, very easy to compare what went wrong. This is me just going through all the various different screens. You click something and you can go through it. You do get videos for all of this as well. And here's another example of a match area just to check the settings and all that type of thing. Okay. So that's essentially what it looks like. I don't need to go through that again. Now, why would you want to do this? So obviously the thing I was showing there was quite a simple project. It's a toy thing. It's a QML demo. But this is very, very useful for large projects. So as a software integrator, it's really, really important to catch regressions going into a system. You don't want to merge something and then a week later find out it didn't work. And when people do manual testing on these disk images, that's very, very easy to happen. It really does happen all the time. So this type of thing can catch those regressions very, very quickly in a pipeline. So in this example, I updated the settings app. That's a video as well. So should go to the next one. So I've updated the settings app. So the workflow for that is I'm literally just changing the SHA. I'm asking the integrator of this project, update the settings app. This is a merge request. And it's got a pipeline. The build was fine, but the test stage has failed. So we can go there. This can't be merged now because the pipeline has failed. So now we can see what exactly happened. And you can see in the settings tests there, it's no longer matching the needle. And you can see there, because the change was making all of the text capital letters, that is now no longer matching against the needle that we expect it to. So we've caught something that shouldn't have got into the system. Now, that might actually be what you want. Perhaps the change is I actually do want to make all of the text in that capital letters. And so you can also do this with GitLab. You can keep all of this in Git. You do a draft merge request to update the tests in your test repository. You come into the main repository, and you say, OK, I want to update the tests, because now it's all in capitals. And you can do a merge request like that. You can update the SHA in your GitLab CI file that you want to test against, and then you can go and test that. And if they pass and fail, you can then update the tests and move along. So you can keep it like that. Now, the biggest problem with this, kster and needleder, that works to clone the needles that you've just defined on the worker. So the correct tests will always get run. You'll always get a pass or fail. So it will be testing those tests on the actual worker instance. But the openQA server, it doesn't use that. So when you go and view a report, the openQA server will base that report based on whatever needles are on the server at that given time. So this is a folder, it's a Git repo, and it will be the ones in master, essentially. So you can actually see very easily what went wrong. So if something did actually go wrong with the test, you can see, it's a bit hard to explain here, but you can see here that it's supposed to be London, but it's New York, and I can't actually see what's gone wrong there because the needles I'm testing against are not on the server. And here's another example. You don't actually get anything in that case. You just know the test failed, but you don't actually get any type of feedback from it. We know the test failed, so it was an error. It just becomes quite difficult then to understand what went wrong. Now, apparently that is fixed upstream. So the merge request there fixes that behavior. So if you apply that patch, you can actually use the web UI in the same way as you can use the worker. So you can give it a SHA, you can give it a test repository, and whenever you view that report, it will use the right version of the needles. They implemented it in their own way, and it's not the same. So I couldn't get the one upstream to work, but there is a patch that does get that behavior. So one of the final points, I've not got much time. There is a needle editor. So if something does go wrong online, you can use this needle editor to edit the needle and fix it. You can say, well, it actually is supposed to look like this, so use that now. We've changed the match area, so fix that. I would recommend not using that because that pushes to things on the server. So it will create a commit in Git on the server, and then it will kind of want to push that upstream. And I think some remote server pushing anything to the main branch is a terrible idea. So I wouldn't use it. You can use it to kind of create the new test, but don't add anything to that. And the other kind of really obscure thing is it will append the date the new needle was created. So all of the old needles still exist. And this actually has caught me out in the past because a test passed when it shouldn't have because it was matching a needle from last year. So a UI had changed, a new update had introduced a regression, and because the old version of that UI needle existed, it matched that. So I just think this workflow for the needle editor is a terrible idea because you are in Git, so you can just update the PNG file and just have one JSON file, one PNG file. Because we can synchronize the tests with the Git SHA, that should always be there. So just do it in Git. So what next? So as I said, all of that was testing in a virtual environment. We do have some open source projects to allow you to do this on hardware very easily. So on the right-hand side there, I think that's like a Raspberry Pi. It's running AGL, automotive grade Linux. And we have this open source piece of hardware called Testing in a Box. And that just allows you to do everything I described there and connect to a physical piece of hardware. It has a CAN bus, it has USB sockets, various different serial. It has a USB switch, which is really, really useful for testing things like someone plugged in a USB stick, someone plugged in an iPhone, all that type of thing. So it's quite useful, and it does help you test on hardware there. And that's it, I think. Any questions?
Actually, can I have a question? Sorry. I mean, I have a project that is. I have a project that is IBus input method, which it's really hard to test the UI behavior on because you have to have an application to test it with. So how do I actually create a needle, let's say, for the interface that is running on? I don't quite catch it.
So that's how do you create a needle? Yeah. The thing is, because those tests, you can do a lot in the actual test itself. So So the test here, you would say assert this screen. So you'd create the needle, and that's what you want it to be. But you can control back-end functionality in there as well. So if there was like a dbus message or something that you needed to send to it to get it to respond, or a CAN message or anything, you can do it there. To create the needle in the first instance, it's not easy. So in the repository I linked towards the end, CodeThink Labs, there is a needle editor that allows you to create the needles from screenshot, essentially. So you can use, it's a web tool which allows you to make the needles in the first instance.
So I have to have a functional thing first to do the screen capture to make a needle.
Yeah, you have to know what it is you're after.
Yeah, but if I want something, but it doesn't work right now, so I couldn't do it.
Yeah, if the UI doesn't exist yet, no. But you can always mock it, right? You can always come up with a new one. Okay, thank you.